In this lesson, we're going to be learning how to calculate the determinant of a matrix using row reduction method. So we're going to be solving this question here on the screen. So let's say that matrix A is equals to this given matrix here. So the first one we're going to do is to reduce this matrix to a row echelon form. When we do that, we're going to have these entries to be 0. The position of this 1, 2, 6 must be 0 for the matrix to be in row echelon form. And then we are going to be applying these rules. So rule number 1 states that when you swap any row, for example, you want to interchange row 1 and row 2 or row 3 and row 1. After interchanging it, you multiply the answer by -1, and that answer is going to be the product of these leading diagonals after you must have reduced this matrix to row echelon form. So we're going to multiply the product of these leading diagonals with -1. That is, if you happen to swap any row, and then if you divide any row by any number, then you also multiply the product of these leading diagonals with that number that you divided with. Alright, we are going to be applying those rules in this question. So feel free to subscribe to my YouTube channel, turn the post notification bell, so that each time I post a new video, you'll be the first to watch it. Also, don't forget to share with your friends, like and comment. So let's start. So the first thing we're going to do here is to swap this row, because we would like to start with 1. Like, we want this 3 here to be 1. Alright, in place of this 3, we want to be 1. That is, the leading entry of this row 1, we want it to be 1. So let's swap this row 2 and row 1. So we swap row 2 and row 1. When we do that, we're going to have 1, 5, 4, then 3, 4, 5, then 2, 6, 2. So as you can see, we have swapped row 1 and row 2. So having 1 here will help us for easier simplifications. So the next thing we're going to do here is to make this 3 to be 0. And so for us to make that, we're going to apply this row operation, row 2 minus 3 times row 1. So to make this 3 0, now we're going to use this row 1. So it's going to be 3 minus 3 times row 1, because 3 minus 3 is 0. So at the same time, we are going to make this 2 here to be 0 by applying this row operation, row 3 minus 2 row 1. So let's apply these two operations to this matrix. When we do that, we're going to remember row 1 did not change, so we have 1, 5 and 4. Then for row 2, so let's apply this row operation. We have row 2 minus 3 times row 1. So here row 2 is 3, then minus 3 times row 1 here is 1. So 3 minus 3 is equals to 0. So we write 0 here. Now for this second entry, which is 4, we're going to write 4 minus 3 into row 1 here is 5. Alright, so this is equals to 4 minus 3 times 5, 15. 4 minus 15 is equals to -11. So we write -11 here. And then this 5, we have 5 minus 3. Then row 1 here is 4. Alright, so 5 minus 3 times 4 is 12. 5 minus 12 is equals to -7. So we're going to write -7 here. Alright, down, let's come to this row 3. The row operation is row 3 minus 2 row 1. So let's start with 2. We have 2 minus 2. Row 1 here is 1. Then 2 minus 2 is 0. Then we write 0 here. Then for this 6, second entry there, we have 6 minus 2 into the corresponding element here is 5 to that column. So 6 minus 2 times 5, so 6 minus 10 is equals to -4. Then we write -4 here. And last but not the least, which is this 2, we have 2 minus 2 multiplied by this 4 here. So this is 2 minus 2 times 4 is 8. 2 minus 8 is equals to -6. And so we write -6 here. So the next thing we're going to do is to make this negative 4 to be 0. And then, but before that, remember we made this leading entry here to be 1. The leading entry here to be 1. So we're also going to make this leading entry here to be 1 for easier simplification. And for us to do that, we are going to divide root 2 by negative 11. Alright, we just want our leading entries to be 1. So row 1 and row 3 did not change. We have 1, 5, 4, then 0, negative 4, and negative 6. Then row 2 is 0, divided by negative 11 is 0. Negative 11 divided by negative 11 is 1. Then minus 7 divided by negative 11 is 7 over 11. So let's go ahead and apply a row operation to this row 3 to make this negative 4 to be 0. And then that row operation I'm going to apply there is row 3 plus 4 row 2. We are going to use row 2 to reduce this negative 4 to be 0. Because if we try using row 1, this 0 here is going to change, or it's going to change, it's going to affect it, but we don't want these two zeros to be affected. So that's why we are using this row 2 to change it, because any operation we use here, because row 3 plus 4 row 2 is just 0 plus 4 times 0 to still give you 0. So let's compute this operation here. So we have minus 4 plus 4 times row 2 here is 1. So minus 4 plus 4 is equals to 0. And then for this negative 6, we have negative 6 plus 4 into 7 over 11. 7 over 11. So this is equals to negative 6 plus 4 times 11 is 28. So 28 over 11. So we're going to punch in a calculator minus 6 plus 28 divided by 11. So this is going to give us minus 38 over 11. Minus 38 over 11. So let me just write it here and then put everything. We have 1, 5, 4, and then we have 0, 1, 7 over 11. Then we have 0, which is and then 0. This 0 is this 0 here, and then for this last element we have negative 38 over 11. Alright, so the answer to this matrix now is the product of these leading diagonals, so which is 1 times negative 38 over 11, then multiply by, remember we swapped row here. Alright, we swapped row 2 and row 1, and we said that when we swapped row, we multiply our answer by negative 1, then times here we divided by negative 11, and so we're going to multiply our answer by negative 11. Alright, so here this negative and negative will cancel to be positive. This 11 and this 11 will cancel, then we'll be left with 1 times negative 38. So this is going to give us negative 38 as our answer. Or let me write to say that the determinant of A is equals to negative 38 using row echelon form. So let's solve this final question. Let's have another matrix A as 1, 1, 1, we have 1, 4, and 3, and then 2, 6, and 5. I asked to find the determinant of this matrix using row echelon form. I want you to pause this video and try this question out. Trust me, this one is very simple. You're gonna get it. Okay, so let's start. Since we already have 1 as the leading entry here, we don't need to swap any row or divide any row by any number. So let's just go ahead and reduce this one and this one to be 0. So for this second row, this row 2, the row operation I'm going to perform here is row 2 minus row 1, because here they are 1, 1. 1 minus 1 is simply 0. And then for this row 3, same row operation I'm going to perform here is row 3 minus row 1. Alright, so when we do that, our row 1 did not change. So 1 minus 1 is equals to 0. Then 4 minus 1 is equals to 3. And then 6 minus 2 is equals to 4. Remember, we are doing row 2 minus row 1. So for this third row, row 3 minus row 1, 1 minus 1 is equals to 0, 3 minus 1 is equals to 2, and then 5 minus 2 is equals to 3. Now we're now going to make this leading entry here, which is 3, to be 1. So because of that, we're going to divide row 2 by 3. So row 2 divided by 3. Remember, we are doing this for easier simplifications. Alright, so when we divide it by 3, the resulting matrix is going to be 1, 1, 2, then 0. 3 divided by 3 will give us 1. Then we have 4 divided by 3. Then we have 0, we have 2, we have 3. So let's now go ahead and perform a row operation. The row operation we're going to perform here is row 3 minus 2, row 2. So remember, in reducing these two to be 0, we are going to use row 2. Alright, so row 3 minus 2 row 2 simply means 2 minus 2 times this one here. Alright, so let's perform this operation. So for this one we have, okay, let me write out this element first. 1, 1, 2, then 0, 1, 4 over 3. Alright, so remember 0, this one is going to be 0, so we're going to write 0 here because it's not going to affect these zeros, it will still be 0. So let's start from here. So I have 2 minus 2 times row 2 here is 1, so 2 minus 4, or rather 2 minus 2 times 1 is 2, 2 minus 2 is equals to 0. Then for this 3 we have 3 minus 2 times row 2 here is 4 over 3, so I have 4 over 3. So this is equals to 3 minus 2 times 4 is 8 over 3. So if you use your calculator and press that, I have 3 minus 8 divided by 3. We are going to be left with 1 over 3. So I have 1 over 3 here. So we're going to multiply this leading diagonals. Alright, so we have that the determinant of matrices is equals to, we have 1 times 1 times 1 over 3, and then times, we didn't swap a new row here, so we're not going to multiply this answer by -1, but we divide by 3 here. Alright, we divide by 3, so we're going to multiply this answer by 3. Okay, so when we do that, we have 1 times 1 times 1 times 1 over 3 is going to give us 1 over 3, then times 3, then this 3 and 3 will cancel. We have that the answer is equals to 1. So we can say that the determinant of this matrix A is equals to 1. So thank you for watching. Please remember to subscribe to my YouTube channel, turn on the post notification bell, and this time I post a new video, you'll be the first to watch it. Thank you for watching.